Right, this is the second part of section 3.4. In this second part, we will be solving radical equations. Equations with square root on them, or maybe two square roots in them. Okay, some steps that might be helpful here in order to solve radical equations is to definitely isolate a radical on one side of your equal signs. The next thing would be to square both sides, and that would get rid of your radical equation, or rather your radical. And then repeat steps 1 and 2 if there happen to be two radicals in the original equation. And then solve for x and check for extraneous solutions. All right, so let's see. Let's dive right in. Let's begin with this first two. Pause the video and see if you can solve these equations, and we'll deal with the graphs at the end. Okay, so hopefully you found some solutions, and now we're just going to compare our answers here. Okay, so we were told to isolate the radical on one side of the equation. In the first example, the radical is already isolated for me. See, there's the square root part is all by itself on the left-hand side of this equation. If it wasn't, I would have to, well, do whatever steps are necessary in order to leave it alone or isolated. So in this particular case, step 1 is already taken care of for me. I have the radical is already isolated. And so now what I'm going to do is I'm going to square both sides of this equation. All right, so that's going to look like this. So I'm going to open a little parenthesis here. Okay. On the left-hand side, what's going to happen is that the square root and the exponent 2, think about them as being inverse operations of each other. So they undo each other, and this just becomes 3x plus 1. And on the right-hand side, I have 16. And now it's just a matter of solving. So let me see if I can solve this. So I'm going to subtract a 1 from both sides. So that's going to say 3x equals 15. Because 16 minus 1 is 15. Divide everything by 3. And so then I should end up with x equals 5. And let me just make sure that if I plug in this solution back into the original equation, I should not end up with a negative inside the square root, and I should end up with the same number on both sides of the equation. So let's check that. So let me check my solution. All right, so this becomes square root of 15 plus 1, and I guess that's the square root of 16, and that is equal to 4. So this seems to be a valid solution. Yeah. Okay, now let's deal with this little graph here. I guess we could solve these equations also graphically if we wanted to. The only thing is that you would be required to know how to graph. So, well, let me kind of explain myself here. Think about these two functions. You have this function y equals the square root of 3x plus 1. And you have the function y equals 4. Let's graph them both in our plane. So in order to graph this one, the top one, you might need a calculator, or you might need to know about how to, I mean, if you remember in the when was it? We talked about transformations of functions. That was, I think, in chapter 2. We gotta identify the parent function, which in this case is the square root of x, and then we gotta identify any transformations that could have happened to the square root of x. And in order to check the transformations that happen, I'm gonna factor out a 3. This becomes x plus 1/3, and now I sort of see what's going on. So this 3 right here is a horizontal compression. This 3, what it does is it compresses my parent function horizontally. The x plus 1/3, what that does is it moves my graph 1/3 units to the left. All right, so and here let me kind of remind you, the parent function kind of looks like this. That would be the square root of x. That's my parent function. Okay, and so what we've done to the parent function is we've compressed it horizontally. So this 3, what it does is it compresses my graph horizontally, and then we've also shifted it 1/3 units to the left. All right, so think about this little graph being compressed horizontally. The horizontal compression is going to be hard to tell because, well, the domain of this thing is from 0 to infinity. So if you compress from 0 to infinity horizontally by 3, you still end up with 0 to infinity. So it's kind of difficult to tell. And so here what we're going to say, let's see, so this goes something like that. And here I'm going to assume that that is 1, negative 1, negative 1/3. And okay, so let's see. I'll do my best here. Let's see if we can make this happen. Well, let me graph the easier one. Let me graph the easier one. Y equals 4. Y equals 4, that's just a horizontal line that hits the y-axis at 4. So this is y equals 4. And the other one that I was trying to sketch over here is the square root one. And they happen to intersect each other right there. Yeah, they happen to intersect each other, those two graphs right there. So this one is y equals the square root of 3x plus 1. And the x value at which they intercept happens to be 5. That's why we concluded our equation had the solution x equals 5, because at 5, these two graphs happen to intersect each other. So that is what's going on graphically. I suppose we could also, actually I'll show you. In your calculator, one thing you could do is the following. I'm gonna go to my where I enter my functions, and I'm gonna enter both of these functions. I'm gonna enter the square root of 3x plus 1, and then I'm gonna enter y equals 4, and then I'm gonna graph. Oops, I put 2 pluses, sorry. So 3x plus 1, now we should be good. Graph. So I have that, and I have that. And so that's kind of what we've concluded. Another thing I could possibly do here is I could go to, you see there's this option up here that says calc in blue. I'm gonna hit second, calc, and right now what I want is intersect. So I'm gonna go to option 5, intersect. I'm gonna hit enter there, and see, it's telling me right now, my calculator is giving me a prompt. It's asking me, where do you think, so on the first curve, where is the intersection point? And I'm gonna use my little cursor, my little keypad here to kind of go towards the intersection. I think the intersection is somewhere around there, I'm gonna say. Right around there, okay, enter. And then on the second curve, it also wants me to move my cursor. Now notice that on the second curve, I'm just moving on the horizontal line. And I want to move the cursor to where I think the intersection is. I think somewhere around there. Hit enter. And then your calculator does a little bit of magic, and it tells you that the intersection is at x equals 5. Yeah? So this would be another way to solve these types of equations graphically using your calculator. Yeah? Okay, so let's get back to manually solving these things. So the next one. Okay, so I gotta solve this equation. The first thing I'm going to do is isolate the radical. So that means I need to leave my square root all by itself. So I'm gonna subtract the 5 from both sides. So I'm gonna have the square root of x plus 7 equals x minus 5. And then I'm going to square both sides of this equation. Okay, on the left hand side, the radical and exponent 2, again, we sort of think of them as inverses, so they undo each other, and this leaves me x plus 7 equals, and then on the right hand side, I am actually going to multiply this out. And if I multiply this out, it should become x squared minus 10x plus 25. So be careful with that in case you're wondering where the heck did he get the 10x, the 25? Well, I had to actually expand this out and do multiplication of a binomial times a binomial. Okay, now I have a quadratic which I'm going to set equal to 0. So I'm going to subtract x and I'm going to subtract 7. Okay, so I should have 0 equals x squared minus 11x and then 25 minus 7. That's going to be 18. Okay, so now I gotta solve a quadratic equation. I could use the quadratic formula, but let's see, can we get away with factoring? Can you think of two numbers that multiply to 18? Multiply to 18 and their sum is negative 11. Well, I think negative 9 and negative 2 are good choices and fit the bill. So I'm going to say, I'm going to factor this factors as x minus 9 times x minus 2. Okay, so let's see. So then that tells me that I have two solutions. I have the solution x equals 9 and the solution x equals 2. Okay, so let's see. Let me just make sure that they're, I mean, again, we gotta check our answers here. So let me check solutions. So let me just check the solutions. All right, so let me check 9. X equals 9. So if I plug it back into my original equation, I have 5 plus square root of 9 plus 7. And on the right hand side, I guess I would have 9. So let's see, 5 plus the square root of 16. Well, that's 5 plus 4. And that equals 9, and that's good. So this is a good answer. Let me check 2. Okay, so if my x is equal to 2, I'm going to have 5 plus the square root of 2 plus 7. And on the right hand side I should have 2. And notice that I'm not putting equal here because I do not know if these things are equal quite yet. I'm checking my answer. I hope that they're equal. So then this becomes 5 plus the square root of 9. And that's 5 plus 3. And 5 plus 3 is not equal to 2. So then that means that this solution, x equals 2, is extraneous. This solution is extraneous, yeah? So, okay, so my answer is 9. And now let's verify this graphically. Let's verify this graphically. Again, I guess now we gotta think about the graph of y equals 5 plus the square root of x plus 7. And I also gotta think about the graph of y equals x and see where they intersect. Now, if you remember your transformations, here my parent function is still the square root of x. So let me sketch it again here. So the square root of x. So that's my parent function. And what this 5 out here does to my function, to the parent function, is it raises it up 5 units. What the x plus 7 does is it shifts it to the left 7 units. Okay, so shift to the left 7 units, up 5 units. That looks something like this. And then it's the same graph, so I guess it's some situation like that. Yeah, this is y equals 5 plus the square root of x plus 7. And now my other graph, y equals x, my other graph is supposed to just be a diagonal. This is y equals x. And I didn't sketch this well. I did not sketch this well at all because they're supposed to intersect each other at x equals 9. The intersection should be x equals 9. So let me sort of tweak my little graph here a little bit. I didn't draw any of them correctly. That's okay. That's why I do not rely on my own graphs. That's why I like to use my calculator sometimes. Makes life a little easier. So that's y equals x. And I guess this graph, it's not supposed to be going down, but it goes something like that. I don't know. So they're supposed to intersect each other at x equals 9. I don't know. Sorry, I'm making a mess of this graph. Let me try to be a little bit more careful here. You get the idea. We'll use the calculator here in a second. So 9 right there, that's where they're supposed to intersect. Let's see, let's use some technology to verify this. So let me go back to my plots. Let me delete them. I'm gonna clear the first one. I'm gonna clear the second one. Let's see, so we had 5 plus the square root of x plus 7. And then my second graph is supposed to just be y equals x. Okay, let's graph both of them. So that's the first one. There's the second one. Good. And then we said second. So second calc. And I'm gonna go to intersect. And I need to kind of move the cursor to where I think the intersect is. So I think it's somewhere right around there. I'm gonna hit enter. And then the second one is also, I think, somewhere around there. Enter. And my intersection is 9. 9,9. All right. So, okay. So hopefully we agree so thus far. Let's move on. So here's a couple more. Again, take a minute, pause the video, and see if you can come up with answers for these questions. All right, so hopefully you have answers. Let's just compare. All right, so this one right here, part C, it's one of those tricky ones that has double radical. Okay, I'm still going to use the steps that were given to us. I'm going to isolate one of the radicals. So I'm going to leave one of the radicals all by itself. Doesn't matter which one. I'm going to do this. So the square root of x minus 3 is equal to 4 minus the square root of x plus 5. Yeah, what I've done here is I've isolated one of the radicals. One of the radicals is all by itself on the left-hand side of the equation. I'm going to square both sides of this equation now. Okay, so that becomes okay. On the left-hand side, this is easy. This just becomes x minus 3. On the right-hand side now, we gotta be a little bit careful. Let's see. I am going to do a little bit of scratch work down here, which I'm gonna erase here in a second. So I'm gonna say 4 minus the square root of x plus 5 times 4 minus the square root of x plus 5. Yeah, that's what it means to square it. It just multiplies by itself. So let's multiply this, and you gotta think here multiplication, or right, if you like to call it FOIL, that's fine. You gotta think that. So this becomes 16 minus 4 square root of x plus 5 minus 4 square root of x plus 5, and then minus square root of x plus 5 times minus square root of x plus 5, that becomes positive x plus 5. Okay, so then that's, let's collect like terms. That becomes x, because of this lonely x right here, and then 16 plus 5. 16 plus 5 is 21. And then negative 4 square root minus 4 square root, that's negative 8 square root. Excuse me. Okay, so the right hand side, if we multiply this out correctly, is x plus 21 minus 8 square root of x plus 5. Yeah. So that's a little bit of scratch work that we had to do in order to figure out what this became. The scratch work is down here, but I'm gonna erase it just for the sake of space here. So you can pause the video and kind of go back to it if you need to. Let me see, can I erase this? Give me 1 second here for my eraser to activate. Let's erase this, we don't need this. This is scratch work, we had to use it just to square. Okay. Okay, so let's go back to the problem. Now let's continue collecting like terms here. So I'm gonna say minus x minus 21 minus 21. So the x's are gone. Now I'm gonna have negative 3 minus 21. That's negative 24 equals negative 8 square root of x plus 5. Okay. I'm going to divide everything by negative 8. That becomes 3. And then I'm going to square both sides again. So this is going to become, so I'm going to say square both sides. So that becomes 9 equals x plus 5. And well, then let's just solve for x. So let me subtract 5. 9 minus 5 is 4. Okay, so that's my answer, supposedly. Now let me just check my solution. Let me just make sure that my solution is correct. Check solution. Okay, so I'm gonna say square root of 4 minus 3 plus the square root of 4 plus 5, and so then this becomes the square root of 1 plus the square root of 9, so that's 1 plus 3, and that is equal to 4, which is kind of what we're supposed to get according to the original equation. So that's a good answer. That is a good answer. Again, we can check this graphically. Well, I guess I'll show you how to do this graphically again once more, but I'm gonna just use the calculator. I don't wanna get into sketching here because my sketch inevitably will be wobbly and not accurate, and well, it's okay. So let's see, let me just use my calculator here. Let me go to my plots, let me clear them. Clear the first one, let's clear the second one. Let me, so I'm going to enter, I don't know, we can work with the original equation, or we could work with this equivalent equation here where we isolated one of the radicals. It doesn't matter. I don't know, I'm kind of curious. I'm going to explore the original equation. So I'm going to say square root of x minus 3. And then plus square root of x plus 5. Okay, so that's my first equation. My second one is just 4. And let's look at the graph. I'm curious. Okay, I guess that's what the graph looks like. And the point of intersection, let's go to second calc. Let's find the point of intersection. Where's my cursor? X equals... There we go. That's interesting. Some x equals, I don't know, about 4. Enter. And indeed, the point of intersection is 4. This is a weird graph. I really don't know what's going on, but we can explore it further in another video. Okay, so that is what's going on. Let's move on to the last radical equation to solve here. Okay, so let's see. Let's think about this one. Again, let me begin by isolating the square root. So I have square root of x minus 1 equals negative 4. Let me square both sides. Okay, so that should become x minus 1, and this should become 16. Because negative 4 times negative 4 is positive 16. Let me add 1 to both sides. And my answer is 17. Let me check my answer. Okay, so I have the square root of 17 minus 1 plus 4. Let's see if that gives us 0. That's supposed to give us 0 according to the original equation. So that's the square root of 16 plus 4. Well, that's 4 plus 4. Well, that's 8. And so therefore, this solution that we found, it's extraneous. So this has no solution. Why is that? Well, we can verify graphically. Think about the transformations that happened on the left. So our parent function is the square root function, which we know how it looks like, or you should know how it looks like if you looked at chapter 2. And so we have our parent function, the square root function. We know what its graph looks like. It's been shifted 1 unit to the right and 4 units up. So 1 unit to the right, 4 units up, that's something like that. And then, so this is y equals the square root of x minus 1 plus 4. That's what it looks like. And now the other function, the one on the right hand side, is just y equals 0. Well, y equals 0 is just the x-axis. This is y equals 0. Yeah, so they do not intersect. These two functions do not intersect. They do not intersect, and so that's why there is no solution in this case. Okay, so hopefully we agree on these answers, and we agree on the method of solving them, and hopefully this calculator usage is I mean, it has its advantages. Sometimes, trying to find the intersection of two functions can become algebraically a little bit complicated, and so maybe graphically it's another method that you have at your disposal. All right, last 3 little exercises in this section. These are just more for practice with algebra rather than solving equations. So the first one is you were given this kind of ugly little equation. It's a rational equation. It's got 3 fractions, and you want to solve for the variable p. You want to isolate the variable p. On the second one, you have a radical equation, and what you want to do is isolate the variable c. And on the last equation, we got to solve that equation. So give yourself the challenge of trying to figure out, of trying to solve for the appropriate variables here, or for, so pause the video, take a couple of minutes, try to solve them. Okay, so hopefully you have some solutions, and let's just compare some answers here. Okay, so let's see. I am going to try to solve this first equation for p. Okay, so one thing I could do is I could multiply. It's kind of like the same strategy that we did a little bit ago when we were solving rational equations. I could multiply both sides of this equation by the least common denominator. That might help. I could just get I could just add and subtract fractions. So there's a couple of correct approaches here. I do not know which method you chose, so I'm gonna just kind of try to solve for p here by using the method that we saw in the first part of this section. So I'm going to first identify the least common denominator. Okay, so it looks like the least common denominator is just going to be f m p. Yeah, f times m times p. So I'm gonna multiply both sides by that. So by LCD. Okay, so then that looks like this: FMP times 1 over F equals 1 over M plus 1 over P times FMP. Okay, so on the left hand side, what happens is this F and that F cancel. So then I just have MP left. This is equal to, on the right hand side, I have to distribute. Okay, and so then this M is going to cancel with this M. And so in this term, I'm just going to have FP. And then on this other part over here, the P is going to cancel with the other P, and so I should just have FM. Yeah, so hopefully you saw what happened there. And now the last thing I'm going to do is I'm trying to solve for the variable P. Yeah, so I notice that I have P on the left hand side of the equal sign, and then I have a term on the right hand side that also involves the variable P. So I'm going to get both terms on the same side of the equation. I'm going to put them on the left hand side of the equation. So that's going to look like this: MP minus FP equals FM. I'm going to factor out a P. And then I'm going to divide both sides by M minus F. Okay, so I've solved for P. And maybe you took a different approach. We should end up with an equivalent expression. All right, so hopefully you got, this one's a little tricky. You could have done this also, I mean, that's one way. Another approach that you could have taken here, you could have also done 1 over F minus 1 over M equals 1 over P, and then get some common denominators, and then cross multiply, and you would have been able to solve also that way. And we should get something equivalent. All right, the next one. Let me solve for C. So in order to start solving for C, the first thing I'm going to do is I'm going to square both sides. Why am I going to square both sides? Because I need to get the C variable, which I need, outside of the square root. Okay, so that's what I have if I square both sides. And then I'm going to multiply both sides by LC. So that's going to look like this. LCW squared equals 1. See, I multiply on the right hand side by LC, I multiplied on the left hand side by LC, and this is what I have. Okay, and so then lastly, I'm going to divide, so I have C on the left hand side, and it's being multiplied by this L times W squared. So I'm going to divide both sides by L times W squared. So C is going to be equal to 1 over L times W squared. All right, so last one. Let's see, the last one. So this one's, we gotta talk a little bit about exponents here. So for instance, if I have x to the 1/3, turns out that that is equivalent to saying the cubic root of x. I guess x to the 1/2 is the same thing as the square root of x. Okay, so right now I guess we could rewrite this as the cubic root of x equals -2. That would be one way to think about it. And so then how do I get rid of a cubic root? Turns out that in order to get rid of a cubic root, one thing I could do is raise everything to the third. Yeah, and so then this becomes just x equals, and then -2 times -2 times -2, that's going to be -8. Okay, so that is it for 3.4, solving radical and rational equations. And thank you, and I'll see you in the next section, 3.5.